We're going to try and clear up some misconceptions about triacs and how to trigger them. Let's move that in focus. What we've got here is a BTA 26 800 volt triac. The MT1, MT2 and Gate are labelled as you can see there, and this is the diagram, the schematic diagram of this part. And what you often see are people trying to trigger this using an optotriac coupled from the Gate to MT1 or the Gate from MT2. So which way is correct? So we either join that to this or this to here. Which way is going to get this triac to trigger? So let's just move this aside and we'll see the little diagram of our test. So this is what we're going to have. We're going to run this off DC because it's going to make it easy. We can use DC to trigger a triac. It won't turn off, but it will still trigger as though it was part of an AC cycle. And we can swap the DC round so that we can see it operate as it would operate in an AC circuit. So we've simply got a bulb as the load. We're going to put volts across here and here, and then we're going to join the gate and put some current in the gate, or take the current out of the gate, because this triac works in many different ways, and they're called 4 quadrants, depending on the polarity of the voltage across here and the direction of the current. So let's just take this and see what we're going to do. So the first thing we're going to do is we're going to put a positive supply up there. We're going to put the negative supply down there, and we're going to join the gate to the negative, just like if we put an optotriac in this path here. When the optotriac conducts, we're going to basically put current through this path here if there's an ability to do so. So we would see an optotriac fitted here with the LED drive. This will be the triac, the phototriac, and we'd have a little resistor in series to limit the current. So that's what we see in many circuits. So this is the first thing we're going to check. So let's zoom out a little bit here. Now what I've done is I've just glued the triac to the piece of paper so that it doesn't move. I've got a resistor from the gate to the yellow wire. I've got a black wire from MT1, and I've got a black wire from MT2, and what I've done is I've connected the bulb, which is a 24 volt bulb, through MT2, and I've got it connected to the positive line of my power supply, which is actually only running at 20 volts, but the lamp will work, and we can show that because if I just put the power supply across the lamp, the triac's not in circuit, the lamp comes on. So what we're going to do now, this is basically, we're going to we've got the positive into MT2 just like we had on this drawing here. The positive goes into the bulb, into MT2 of the triac. MT1 is up here. I'm going to connect that to the negative of the power supply, and the gate will remain open. So okay, the gate is open, it's floating, there's no current in or out of the gate, the triac is off. Now what I explained earlier is that people will put an optotriac in between the gate and MT1. So this is where you would see some circuits put an optotriac. So in here the triac will get triggered when there's a voltage on the LED. That's probably not very clear, but you should understand what I'm saying. The resistor is simply to limit any current that's going through to a safe level. In this case, I've got a 390 ohm resistor. I calculated it. If it was about 400 ohms, I would get no more than 50 milliamps because I've got 20 volts in the whole circuit. 400 ohms gives me 50 milliamps, so I'm going to be safe no matter what goes on here. I'm not going to overload the gate. So let's pretend we've got an optotriac in this circuit. The gate is going on the yellow wire. I'm going to join that to MT1 and see what happens. Nothing happens on MT1, so it's quite clear that the triac in this configuration does not turn on with the gate on MT1. If I connect it to MT2, however, it comes on and stays on. So that won't go off now until I turn the power supply off, turn the power supply back on again, and it's latched off. So it only latches on once we trick to MT2, just like that. So we know that's one way of getting the circuit to work. Let's reverse the polarity. So now let's take the negative supply down to MT2 and the positive goes to MT1. Let's see what happens in this case. Oh look, it still doesn't work, but if I go to MT2 it still doesn't work. That's because the power supply is off. Let's turn the power supply on. Power supply's on. MT1 doesn't trigger. MT2 it triggers. So let me turn that off. The correct and only solution for this is to have let's draw on a new sheet of paper. Right, we've got another piece of paper now. Hopefully this is better. The Triac symbol here with the MT1 and MT2 and the gate. The easy way to remember this is the path from here to here that you want to put your optotriac in. You don't want to put it in this path here. Okay, so there's the optotriac. This is the one that doesn't work. This is the path that does work.